children, hearty welcome to today's class. In the previous modules, we were discussing about the surface tension, factors affecting surface tension, consequences of surface tension. From this module onwards, we are discussing another property of liquid, that is viscosity. In this module, we discuss the definition of viscosity, coefficient of viscosity, fluidity. Then finally, we will discuss the factors affecting viscosity. Let us see each one by one. First, let us discuss viscosity of a liquid. We have heard this word often. Viscosity is nothing but the resistance of a fluid offers to the flow of the another part of it. That means it is something, the resistance of the fluid. The resistance of something will be offers to the flow of the another part of the, or affecting the flow of the another part of the fluid. That is viscosity. That means opposition to flow. Viscosity denotes opposition to flow. It may be regarded as an internal friction operating within a fluid produced by the shearing effect that results when one layer of fluid moves past another. Here we consider liquid as in different layers, and the movement of the one layer of the fluid will affect the movement of the another layer. That means the shearing effect. That means the opposition force. If the force is acting like this, one side, there will be another force here. So because of this, opposite force is nothing but the shearing effect. So because of this shearing effect, the internal friction occurs. Because of the internal friction, the liquids finds difficulty to flow. That is viscosity. Viscosity is an internal friction operating within a fluid produced by the shearing effect that results when one layer of fluid moves past another. Because of the shearing effect of the fluid, the one layer will move fast, another layer will move slow. That is the viscosity. So let us see this viscosity in detail. We have a common observation in our lab. We have seen that the water, kerosene, oil, ether or petrol, that flow very easily. But honey or glycerol, they find difficulty to flow. That means this honey and glycerol are more viscous compared to our petrol, water and kerosene oil. Coming to the definition of the viscosity, it is the property, viscosity of a liquid is the property of internal resistance to flow. This is the internal resistance to flow, some difficulty to flow. What is the reason for the internal resistance to flow? That is, which arises due to the intermolecular forces that hold its layers. I said that the fluid is having different layers, and because of the intermolecular forces that hold the layers, the internal resistance occurs. Because of this internal resistance, the liquid is having difficulty to flow. If some liquids are having more internal resistance, that liquids will be more viscous. If the internal resistance is low, that liquids will be having low viscosity together and thereby oppose the movement of layers past one another. Because of the intermolecular forces that hold these layers, what will happen? The movement of the one layer will be slow. That is viscosity. So the definition of the viscosity is viscosity of a liquid is the property of internal resistance to flow which arises due to the intermolecular forces that hold its layers together and thereby oppose the movement of layers past one another. Viscosity of the liquid is the property of internal resistance to flow which arises due to the intermolecular forces that hold its layers. Because of that, what will happen? Thereby oppose the movement of layers past one another. That is viscosity. Then the viscosity varies as the strength of the intermolecular forces varies. If the strength we saw in the beginning of this chapter as the molecules, the liquids, in the liquids, the molecules are held together by an intermolecular forces, intermolecular attractive forces. If the intermolecular attractive forces are strong, that liquids will be more viscous. If the strength of the intermolecular forces are less, that liquids are less viscous. That is, the internal friction obviously varies from liquid to liquid because the strength of intermolecular forces also varies from liquid to liquid. So, if the water will flow very easily because the internal friction is less, the honey will have more internal friction. That means the intermolecular forces in the honey is high, and because of that, honey is more viscous. Liquids which offer less resistance to flow are said to be less viscous or said to have low viscosity. Similarly, the liquids which offer greater resistance to flow are said to be more viscous or said to have high viscosity. So, we have low viscosity liquids and high viscosity liquids. Low viscosity liquids are having less resistance. That means the intermolecular forces will be less, and the high viscosity liquids have the strength of the intermolecular force will be more, and that means the internal friction also will be more. Let us consider the streamline flow of the layers. Here we have the streamline flow of the layers, and each line is considered as the layers of the fluid, and the layer which is adjacent to the solid surface. The layer which is adjacent to the solid surface is stationary, and the velocity of the layer which is adjacent to the solid surface will be less. The velocity will be less, the layer which is adjacent to the solid surface. As the distance between the layer and the solid surface increases, the velocity increases. Here in this layer is having velocity this much, and this layer is having the viscosity this much, and the center layer is having the maximum velocity, and here the velocity will be like this, and this layer is having velocity like this, and this layer is having less velocity because this layer is attached very near to the solid surface. So, the velocity of the layer just in touch with the side of the tube is 0. So, this is the layer which is adjacent to the side of the tube. Therefore, the velocity will be almost 0. And from this figure, we can understand that as we proceed towards the center of the tube, the velocity increases. As we proceed towards the center of the tube, the velocity increases. Then the velocity also depends upon the velocity of the adjacent layer. The adjacent, because the layer moving, the movement of the layer is affected by the movement of the adjacent layer. That is what the viscosity occurs. Okay, I hope you understood the example. This is the streamline flow of the layers of the tube. And here we consider the fluid as different layers, and the layer which is adjacent to the solid surface is having the velocity almost zero. As we proceed from the from adjacent to the tube to the center of the tube, the velocity increases. So here at the center of the tube, the velocity will be maximum, and the velocity which is adjacent to the solid surface will be zero. Okay. Therefore, because of the intermolecular attractions present, the molecules of any one moving layer tend to impede the movement of the molecules in the adjacent faster moving layer. So, here if we consider this layer, the movement of this layer is affected by the movement of this layer and movement of this layer. So, that is what telling here, that is because of the intermolecular attractions, the movement of the velocity of the one layer is affected by the movement of the adjacent layer. Because of the intermolecular attractions, the movement of the one layer is affected by the movement of the adjacent layer. In other words, each layer experiences a frictional force called a viscous drag from the adjacent slower moving layer. Each layer experiences a frictional force called a viscous drag from the adjacent slower moving layer. Viscous drag is experiencing. The reason for the viscous drag is the intermolecular attractions. So, because of the intermolecular attractions, each layer experiences a frictional force called a viscous drag from the adjacent slower moving layer. The retarding influence of the slower moving layer on the adjacent faster moving layer is manifested as resistance to flow or viscosity. We said that there is a retarding influence for the slower moving layer on the adjacent faster moving layer, which is manifested as resistance to flow. In other words, we can say that is viscosity. The retarding influence of the slower moving layer on the adjacent faster moving layer is manifested as resistance to flow or viscosity. So, this is about viscosity. Let us go through once again about the viscosity. Here we saw that the viscosity is nothing but the resistance of a fluid, or we can say that is the internal friction, and this viscosity depends upon the strength of the intermolecular forces. That means the intermolecular forces are high, means that liquids will be more viscous. If the intermolecular forces are less, then the internal friction will be less, that liquids will be low viscous liquids. Then we saw that the example of the streamline flow. That means if we consider the fluid as the different layers, the layer which is adjacent to the solid surface, the velocity will be zero, and as we proceed to the center of the tube, the velocity increases, and the center of the tube is having the maximum velocity here, because the velocity decreasing because of the opposing force or the internal friction of the adjacent layer. That is what we say, that is the internal friction, or each layer experiences a frictional force called a viscous drag from the adjacent slower moving layer. Okay, I hope you understood about the viscosity. Viscosity is nothing but the resistance to flow. Why the resistance to flow? Because of the influence of the adjacent layer. Now, we move on to the coefficient of viscosity. Another aspect of viscosity, that is coefficient of viscosity. Here we consider two parallel liquid layers. We consider the parallel liquid layers with the area of the plate A and the distance between the layers as dz. Here the distance between these two layers is dz and these two layers is dz, and the velocity of this layer is u plus du and this layer is u and this layer is u minus du. Then the velocity gradient between the two layers, that is du by dz. Du by dz is the velocity gradient. Velocity gradient between the two layers is du by dz. So, we saw that there is a resistance to flow. When there is a resistance to flow, there will be another force acting against the resistance to flow. That force is directly proportional to the area in contact. That is, this force is directly proportional to the area of contact and the velocity gradient. Velocity gradient. So we can write it as F is directly proportional to A into du by dz. Du by dz. So the proportionality constant, if you remove the proportionality, that is eta A du by dz. This eta is called the coefficient of viscosity. This proportionality constant eta is called the coefficient of viscosity. How it comes? That means when there is a resistance to flow, there will be another force opposing to the resistance to flow. That force is proportional, directly proportional to the area of the plate and the velocity gradient du by dz. That is, F is directly proportional to A into du by dz. Therefore, when we remove this proportionality, F is equal to eta A du by dz. This eta is called as proportionality constant or the coefficient of viscosity. When this A is equal to, when we consider this equation, when this A is equal to 1 and du by dz is equal to 1, what will happen? F is equal to eta. That means the force will be equal to the coefficient of viscosity. Here, the definition of coefficient of viscosity comes, that is, it is defined as the force per unit area. So, coefficient of viscosity is defined as the force per unit area required to maintain unit difference of velocity. Required to maintain unit difference of velocity between two parallel layers unit length apart. That is the coefficient of viscosity. Coefficient of viscosity is defined as the force per unit area required to maintain unit difference of velocity between two parallel layers unit length apart. Okay, I repeat once again, the coefficient of viscosity eta of a liquid is defined as the force per unit area required to maintain unit difference of velocity between two parallel layers unit length apart. That means here in the equation F is equal to eta A du by dz. When A is equal to 1, du by dz is equal to 1. F is equal to eta. Therefore, the coefficient of viscosity is defined as the force per unit area required to maintain the unit difference between the two unit difference of velocity between the parallel layers unit length apart. Okay. Then let us see the unit of coefficient of viscosity. So here we have an equation. F is equal to eta A du by dz. Now the eta is equal to F divided by A into du by dz. The unit of force is Newton. The unit of force is Newton. Then the unit of area is meter square. Since this is in denominator, that is meter inverse square. Then the unit of the velocity gradient du by dz is s inverse second inverse, and since this is in denominator, that is second. So the unit of coefficient of viscosity is Newton meter inverse square second. That is the unit of coefficient of viscosity. The coefficient of viscosity is a measure of viscosity. Coefficient of viscosity is a measure of viscosity. That means if the value of coefficient of viscosity is greater, then the liquid will be more viscous. That means the mobility of the liquid will be less. I repeat, the coefficient of viscosity is a measure of viscosity. The greater the value of coefficient of viscosity of a liquid, then the greater will be the viscosity, then the mobility of the liquid will be less. Or we can say that lower the value of coefficient of viscosity of a liquid means the liquid will be less viscous and the mobility of the liquid will be more. Okay, I hope you understood the coefficient of viscosity. Here we have the definition of coefficient of viscosity. That means the resistance to flow of the liquid is having some opposite force. That opposing force is directly proportional to the area of the plate and the velocity gradient. From this we will get the coefficient of viscosity. The coefficient of viscosity is defined as the force per unit area required to maintain the unit velocity difference between the layers unit length apart. And we saw the unit of coefficient of viscosity. Then we saw that the coefficient of viscosity is a measure of viscosity. If we have the more value of coefficient of viscosity, then that liquids will be more viscous. That means the mobility of the liquid will be less. Then if we have the low value of coefficient of viscosity, then that liquids will be less viscous and the mobility of the liquids will be more. This is about the coefficient of viscosity. Now, let us discuss another property, that is fluidity. As the name, fluidity is reciprocal of viscosity. Reciprocal of viscosity is called fluidity. That means fluidity is a measure of ease with which a liquid can flow. Measure of ease with which the liquid can flow. How easily the liquid can flow, that measure is called it as fluidity. The measure of the ease of the liquid can flow. That is fluidity, which is the reciprocal of viscosity. This we can represent by theta. Theta is equal to 1 by eta. Theta is equal to 1 by eta. Theta is the fluidity and which is the reciprocal of viscosity. Okay. Now, let us discuss about the connection of viscosity and intermolecular forces. If the strength of the intermolecular forces are strong within the liquid, then the greater will be the resistance of the liquid. If the resistance of the liquid is greater, what will happen? Automatically the viscosity will be more. That is, here we have written, the stronger the intermolecular attractive forces within a liquid, the greater the resistance to the flow of liquid layers and greater the viscosity, and vice versa. If the intermolecular attractive forces are less within the liquid, then the resistance will be less. If the resistance of the liquid layers are less, means the viscosity also will be less. We have the viscosity values of some liquids. Here we have the values of water, glycerol, acetone, aniline, ethanol, methanol. And we have different values. When we look into these values, the glycerol is having higher value, that is something like 1 into 10 power 4. So, if we look into these liquids, those liquids which have higher viscosity are having high intermolecular forces. So, obviously, glycerol is having higher value compared to all other liquids. The glycerol is having greater intermolecular forces of attraction. Because of the greater or stronger intermolecular attraction and the intermolecular hydrogen bonding, glycerol is more viscous. That is written here. If the attractive force prevailing in the liquid are stronger, the flow tendency of a mobile layer will be checked by the attractive force exerted by the stationary layer. This increases viscosity. So, the stronger the intermolecular attraction, then the liquid viscosity will be higher. The very high value for glycerol is a consequence of larger molecular size and extensive intermolecular hydrogen bonding. Here, all these liquids are having some strong intermolecular forces. Compared to the all other liquids, the glycerol is having higher value. That means the intermolecular force of attraction of glycerol is high, and the intermolecular hydrogen bonding also high in the case of glycerol. This is about the viscosity and intermolecular forces. If we conclude these intermolecular forces and viscosity, one point is that if the strength of the intermolecular forces are high, then the liquid will be more viscous. If the strength of the intermolecular forces is less, then the viscosity will be less. Now, let us discuss the factors affecting viscosity. First factor is increase of temperature. If we increase of the temperature, will decrease the viscosity. The second factor is if we add some impurities in the liquid, then the viscosity will be higher. Then third one is if we consider a homologous series, as the molecular size increases or the molecular mass increases, the viscosity will be increasing. Then the fourth point, if the alkyl chain is having more branches, then that liquids are having more viscosity. Last point, if the liquid is having intermolecular hydrogen bonding, the viscosity will be increasing. These are the 5 factors which affect the viscosity. I repeat once again. First point is increase of temperature decreases the viscosity of a liquid. Second point is presence of other substances such as colloidal matter increases viscosity. Third point, in the case of a homologous series, viscosity increases as the molecular mass increases. Then fourth point is viscosity increases as the branching of the alkyl chain increases. Fifth point is viscosity increases due to intermolecular hydrogen bonding. These are the factors which affect the viscosity. First thing is temperature. Second one is if we add some impurities to the liquid, then the viscosity will be increasing. Third one is if we consider a homologous series, then the molecular mass increasing means the viscosity will be higher. Then as the branching of the alkyl chain increases, the viscosity increases. Finally, if the intermolecular hydrogen bonding is high, then the viscosity also will be high. This is about the factors affecting viscosity. Now, let us discuss something more about the viscosity and temperature. Viscosity and temperature. We saw that with the increase of temperature, the viscosity decreasing. What is the reason? While increasing the temperature, the average kinetic energy of the molecules increases. The kinetic, that means the molecules can move easily as the temperature increases. So that means the intermolecular attractive forces can overcome. The molecules can overcome the intermolecular attractive forces. That is what the viscosity is decreasing if we increase the temperature. Here we have, with increase in temperature, molecules get greater kinetic energy, thereby it becomes easier for them to overcome intermolecular attractive forces. As a result, one liquid layer is able to slip past another with more ease. In other words, viscosity of a liquid decreases with increase in temperature. If we increase the temperature, first thing is kinetic energy will increase. If the kinetic energy increases, the molecules can overcome the intermolecular attractive forces, thereby the viscosity will decrease. Okay, I hope you understood the effect of temperature with the viscosity. The temperature dependence of viscosity is studied by Arrhenius, and here we have an equation for the temperature dependence of viscosity, that is eta is equal to AE power E by RT. Eta is equal to AE E by RT, where eta and A are constants. R is gas constant, E is the temperature, and E is the activation energy required for the viscous flow. Activation energy required for the viscous flow, that is E. Then if we take the logarithms, eta will become ln eta, and here we have ln A plus E by RT into ln E will come. This ln E is nothing but 1. Therefore, we can cancel that one. Therefore, ln eta is equal to ln A plus E by RT. Here only this much we have written because ln E is 1. Okay. If we take the logarithms of this equation, we can write it as log eta is equal to log A plus E by 2.303 RT. Log eta plus log A plus E by 2.303 RT. This is the equation to find out the activation energy for the viscous flow. Okay, here if we plot the graph of log eta versus 1 by t, that is if we plot the graph versus log eta versus 1 by t, will get a straight line with the slope E by 2.303 R. This is the slope we'll get from this equation. Okay, this is the slope we have, and this is log A is the intercept. Therefore, we can verify this equation. log eta versus, when we plot the graph of log eta versus 1 by t, we get a straight line with the slope e by 2.303 r and the intercept of log a. Okay. If we have the viscosity of the two liquids, that is log eta 1 is equal to log a plus e by 2.303 RT1, and log eta 2 is equal to log a plus e by 2.303 RT2. So these are the viscosity, coefficient of viscosities of the two liquids, and from this we can find out the ratio of the viscosities of the liquids, that is log eta 1 by eta 2. That is log eta 1 minus log eta 2 we are writing. If we consider this is the first equation and this is the second equation, if we subtract the second equation from first equation, log eta 1 minus log eta 2 will come. That is nothing but log eta 1 divided by log eta 2. Then this log a minus log a, that will be equal to 0. Then we have e by 2.303 r as common. 1 by t1 minus 1 by t2 will come. 1 by t1 minus 1 by t2 will come. So when we make this as common denominator, t1 t2 will come in the denominator, and in the numerator t2 minus t1 will come. Therefore, we have the equation log eta 1 by eta 2 is equal to e by 2.303 r into t2 minus t1 divided by t1 t2. So this is the equation which can be used to calculate the activation energy for viscous flow of the liquid. So this is about the temperature dependence of viscosity. If the temperature is increasing, the activation, if the temperature is increasing, the kinetic energy of the molecules will increase. Because of the high increase of the kinetic energy, the molecules can overcome the intermolecular force of attraction, and then the liquids can flow very easily. That means the viscosity of a liquid decreases with increase in temperature. Viscosity of a liquid decreases with increase in temperature. The temperature dependence equation is log eta is equal to log a plus e by 2.303 RT. When we plot log eta versus 1 by t, we get a straight line with the slope of e by 2.303 r. And if we have two liquids with the viscosities eta 1 and eta 2, and to find out the activation energy for the viscous flow, we use the equation log eta 1 by eta 2 is equal to e by 2.303 r into t2 minus t1 divided by t1 t2. So in this module, we discussed about the definition of viscosity, then what is fluidity, what is coefficient of viscosity, then the factors affecting viscosity, and the temperature dependence of viscosity. I hope you understood all these data about the viscosity. Thank you.